About parametric equations, and so first of all, you're going to notice on the sheet I gave you, we're going to define what a parametric equation is. I won't need that. So a parametric equation is a method of defining a relation using parameters. Okay, a parameter is t. So you have seen rectangular equations, which example is y equals negative 2x squared plus x plus 40, and we're going to talk about parametric equations right now. So an example of a parametric equation is x equals 30 times root 2t, and then y equals negative 16t squared plus 30 root 2t plus 40. So that's an example of what parametric equations look like. And so what we're going to go ahead and do is we're going to go ahead and look at this second one right here. Okay, so notice, x refers to your horizontal, y refers to your vertical, and your parameter is t. This is used to determine where the object was at a given or specific time. Okay, x is always going to be like f of t, y is always going to be g of t. So let's go ahead and look at what this says. It says sketch the curve given by each pair of parametric equations over the given interval. So they give you that x equals t squared plus 5 and y equals 0.5t plus 4. They tell you t is between negative 4 and positive 4. So what I did is create a table. And so that's what you're going to have to do. When they give you those values, you're going to create a table based on those constraints that they give you. So then now all I'm going to do is I'm going to plug in negative 4 for t in the x equation. So if I plug negative 4 in for the t in the x equation, I get negative 4 quantity squared plus 5, which is what?
21.
21. Now I'm going to do the same thing with negative 3. 14. Okay, what about the negative 2? 9.
6.
Okay. 5. Okay.
9.
I'm going to guess 14. Okay, so those are your values for x. Now we're going to do the same thing with the y. So I'm going to plug negative 4 in here for t. So if I plug negative 4 in, what do you get?
Negative, or not negative. Yeah.
6?
It's 2.
2. Okay, so if I plug negative 3 in, what do I get? 2.5. Good. What's the next one?
3.
3. What's the next one? 3.5.
I said that, did I not say that?
What's the next one?
4.
4. Then,
3.5.
then,
3. 2.5.
okay, what's the next one?
I thought we were going back down.
5. What's the next one? Okay,
Are you sure we're at 6?
and 6. So then now, all of these are ordered pairs that you need to plot. Okay, now we've got an issue because how far does x go? To 21. Okay, so let's look. What do you think we should go by x's on here?
7.
3's. 3's a good rule of thumb. Okay, here. So we're going to go ahead and go by 3's. What about for the y's? What do you think we should go by?
7.
I'd probably go by 1. Because it goes all the way up to 6. 1, 2, 3, 4, 5, 6. Yeah. So then now let's go ahead and plot. We have 21 and 2. So 3, 6, 9, 12, 15, 18, 21, and 2. So I'm going to put a dot. The next one will be 14, 2.5. So 14 is going to be about 2/3 of the way to 15, and then 2.5. Okay, next one will be 9, 3. Okay. Next one will be 6 and then 3.5. Next one will be 5 and then 4. Then the next one will be 6 and then 4.5. Oh, just a second. That 3.5 I did wrong. Sorry, there we go. The 9 and 5 is going to go here. The 14 and 5.5. And then the 21 and 6. So what does it look like, guys? A parabola that opens? Right. Yep. So there you go. That's how you graph parametric equations. We're going to look at one more for today.
That's pretty easy.
So let's go ahead and look at one more. Sketch the curve, again, given by each pair of parametric equations over the given interval. So once again, if you notice, it says we're going from -8 to +8 for t. So I went ahead and went by 2's. So let's go ahead and plug in -8. So into the x equation, you're going to square it, take it times 0.25, and then add 5. So what do you get?
21.
Okay, 21. What do you get for the -6?
14.
Okay. What do you get for the -4?
9.
What do you get for the -2? 6.
Yeah.
What do you get for 0?
0.
5.
6.
Okay.
6, 9, 14, 21.
Now, will it always go up like this? No. In this case, it does because it's a square. Okay, so with the squared, the positive and negative stay the same. So where are those numbers looking really familiar from?
The last one.
Yeah, the last ones. Okay, so let's go ahead and look at -8. Let's plug in -8.
Exactly.
What do I get when I plug in -8? 2. What do you get when you plug in 14? Or I take that back, when you plug in -6, I said the wrong thing. When you plug in -6, what do you get?
2.5.
2.5. When you plug in -4, what do you get?
3.
Okay.
I'm assuming it's the same as the last one,
What are you doing here?
Yeah.
What's the next one?
but
2.5.
assuming it's wrong.
And
4.
so what do you notice?
It's the exact same.
It's the exact same thing as the last one. Okay, so really you're going to get the exact same graph. Basically, the whole purpose of what I was showing you on this one is that you can have parametric equations give you the same graph just by changing a little bit on the t value
These are double.
and just by changing the equations just a bit.
Did she like say that?
Okay? So anyway, what I need you to do is start working on your assignment from this section. This is your assignment, page 469. I need you to start working on 2 through 16, the evens. Okay? 2 through 16, the evens. Now tomorrow we're going to finish up this section and we're going to go ahead and write in the rectangular form, so the other 2 problems on the bottom of your sheet. Okay?
Those hard.